Okay, to get the antiderivative of t to the negative 1/2, we follow the same procedure we did for t to the 1/2. We first figure out what the power of the function is. It's a power function, and the power is negative 1/2. It doesn't take much figuring. The antiderivative, therefore, must be a multiple of what power of t? Well, taking the derivative, the power goes down 1. If you're doing an antiderivative of a power function, the power goes up 1. So the power has to go up 1. Power is negative 1/2. 1 greater than that is 1/2. Negative 1/2 plus 1 equals 1/2. So now you're talking about power 1/2. That would be the function t to the 1/2. But what is the derivative of t to the 1/2? Is it t to the negative 1/2? Well, no. If you take the derivative of t to the 1/2, you get 1/2 t to the negative 1/2. And then that's progress because you have the right power of t, but you have that 1/2 there. And all that means is, well, what multiple of t to the 1/2 do you have to take the derivative of to get t to the negative 1/2? If you take the derivative of t to the 1/2, you only get half of t to the negative 1/2. If we want to get t to the negative 1/2, then we'd better take the derivative of twice this, which will give us twice this, which is t to the negative 1/2. Okay, so we find that the antiderivative of t to the negative 1/2 with respect to t is 2 times t to the 1/2, and in general, plus a constant. And if you take the derivative of this, it's very easy to see that you do get t to the negative 1/2. Now we want to apply these ideas to this antiderivative. And of course, the square root of t squared over 4 can be simplified to t over 2. That'll give us a good check, but we want to go through the process we've been using, starting with u equals t squared over 4. Why u equals t squared over 4? Well, that's the inner function of this composite function here, and that's usually what we're going to focus on when we're doing u substitution, because u substitution is a backwards application of the chain rule, and it's the inner function that's kind of the crux of the process. So generally, if we've got a composite, the first thing we're going to try, won't always work, but the first thing we try is letting u equal the inner function of the composite. And we're going to treat this as a composite. Again, we're not going to simplify this to t over 2 here. Okay? So we follow the process, and here's the process we used in the preceding example, just to remind you of the details that we want to document as we go through the entire process.